So we still don't know what k is. We still don't know what E is. But at least we know that it's there somewhere. Yeah?
How do you know it's f of kx?
How do I know? Well, f of x is 2 to the x. If f of x is 2 to the x, then the formula for f kx is this. I've decided what f of x is. So therefore, there's a formula for f of kx. And furthermore, by the chain rule, there's a formula for the derivative. And it's k times the derivative of f. So again, scaling does this. By the way, we did exactly the same thing with the sine and cosine function. If you think of the sine function here, let me just remind you here, what happens with the chain rule, you get k times cosine kt here. So the fact that we set things up with, it's beautifully with radians that this thing is, but we could change the scale to anything, such as degrees by the appropriate factor k, and then there would be this scale factor shift of the derivative formulas. But of course, the one with radians is the easy one because the factor is 1. The one with degrees is horrible because the factor is some crazy number, right, like 180 over pi or something like that. Okay, so there's something going on here which is exactly the same as that kind of rescaling. Okay, so far we've got only one formula that I'm going to, which is a keeper here, this one. All right, we have a preliminary formula that we still haven't completely explained, which has got a little wavy line there, and we have to fit all of these things together. Okay? So now, to fit them together, I need to introduce the natural log. So the natural log is denoted this way, ln of x. So maybe I'll call it a new letter name. We'll call it w is equal to log x here. But if we were reversing things, if we started out with a function y is equal to e to the x, the property that it would have is that it's the inverse function of e to the x. So it has the property that the log of y is equal to x. All right, so this defines the log. Now, the logarithm has a bunch of properties, and they come from the exponential properties. And in principle, you remember these. And I'm just going to remind you of them. So the main one that I just want to remind you of is that the logarithm of, the logarithm of x1 times x2 is equal to the logarithm of x1 plus the logarithm of x2. And maybe a few more are worth reminding you of. One is that the logarithm of 1 is 0. A second is that the logarithm of e is 1. All right? So these correspond to the inverse relationships here. If I plug in here x equals 0 and x equals 1, if I plug in x equals 0 and x equals 1, I get the corresponding numbers here, y equals 1 and y equals e.